Hello everyone, welcome to the lecture of optical networks. My name is Sandeep Kumar Singh, and in the last lecture, we talked about the textbooks that we are going to refer in this course, and we also discussed the course contents. We saw the benefits of fiber optical networks in terms of high bandwidth, low weight and size, low signal loss. So the reachability increases in terms of hundreds of kilometers as compared to the copper wire networks, and flexibility and immunity with respect to the electromagnetic interference. The one disadvantage that fiber optical networks still has is the high equipment cost, which will eventually come down as the networking technologies get mature. In today's lecture, we will talk about the overview of optical networks. Let's look at the introduction of the optical networks. An optical network is a communication system that uses light signal to carry the information between two or more points. The points could be two computers in a room, or two data centers, or even two or more countries. In an optical communication system, in its simplest form, should have an optical transmitter, an optical channel, and an optical receiver. Optical channel can be either fiber-based or free space. In this course, we will mostly cover the fiber-based optical communication networks. In addition to that, if we would like to transmit the optical signal over long distance, more than hundreds of kilometers, then we will need amplifier, optical amplifier in particular. And if we want to connect multiple endpoints, then we will need optical switches also to direct the signals to their destination. And we will require other components, example, optical filters, optical splitter, etc., that we will look during this course. So given the net optical devices, for example, the optical transceivers, this is an SFP, a small form factor pluggable device that has two ports, one transmits and another receives, and optical fiber cable, optical amplifier, and optical switch. How can we build optical networks? So any idea? So in point-to-point communication, it is easy. So we can interconnect the two transceivers by simple fiber. And if we want to reach the long distance, then we can also connect the optical amplifiers. In point-to-multipoint, we will need the optical splitter to split the signal to reach the multiple destinations. In switched networks like telephony or data centers, we need optical switches to interconnect these different devices. And within a metro city, we can interconnect different optical switches and different end nodes. For example, mobile and access points can be interconnected with an optical switch, and data center can be interconnected to an optical switch. And different metro sites can be interconnected with multiple optical backbone networks. So even we can interconnect two different countries through subsea optical cables. And this is the beauty of optical networks, that from any continent to any continent, data can be transferred over optical networks. So the main building blocks of these optical networks are the optical fiber and optical switches, optical amplifiers, and many of these devices. Let's look at briefly one by one. An optical network carries data through the optical signals. An optical signal consists of optical pulses. For example, when we have the data in the form of digital, then what we would like to generate are the optical pulses corresponding to these ones and zeros. How can we do that? So we need to modulate the light carrier, right? So this can be done in two ways. One is called internal modulation and another is called external modulation. And also these two techniques are the on-off modulation. So here, an electrical signal, which is a modulating signal and carries the messages. So this drives a laser on and off based on the ones and zeros. So it modulates the light output. In external modulation, an external modulator is used and is driven by a modulating signal, which is the message signal in the electrical domain, and it drives the laser externally on and off to generate the modulated light output in the form of on-off modulation. So once we generate the signal, we need to consider many other things like how fast we can drive these lasers on and off. That defines the data rate. How should be the signal width, the pulse width. And because when an optical signal travels, then it gets broadened. And this is because of the fact that different wavelengths travels at different speed in the silica-based optical fibers. And one way to compensate this is to use the dispersion compensated fiber. Another thing that you need to consider is how can we increase the data rate? So it can be done by multiplexing several optical signals in the wavelength domain, which is analogous to the frequency division multiplexing. And here in optical networks, we call it wavelength division multiplexing. So consider an example with a wavelength carrying 10 gigabit per second. And if we are able to multiplex 80 or hundreds of these wavelengths, then we can increase the total data rate by that many factors, 80 times or 100 times. So in terabit per second, we can transmit the signal together. The next important building block is the amplifiers in the long distance communication. Let's consider an example of 100-kilometer transmission with a fiber attenuation of 0.2 dB per kilometer. So the total loss will be 20 dB. And if the transmit power is 0 dBm, the receive power will be minus 20 dBm. And if the receiver sensitivity is below minus 20 dBm, then we will be able to detect the signal. So we will not need the optical amplifier. But if the transmission distance is more than hundreds of kilometers, then we will need multiple of these optical amplifiers to strengthen the signal. The most commonly used optical amplifier is the erbium dope based. Here, erbium dope based optical fiber is used and an optical pump laser is used. So the photons emitted by this optical pump is absorbed by the erbium dope atoms, which releases the photons in the entire band of the signal transmission. And thus it multiplies the number of photons in this range, meaning that it amplifies the signal. Another commonly used is the semiconductor optical amplifier, which uses the semiconductor gain region to amplify the signal. Now you may have a question about for thousands of kilometers, how many amplifiers do we need? So this depends on multiple factors, including the amplification gain provided by the amplifier, input signal power coming to the amplifier, then what is the transmission distance, what is the signal attenuation in the fiber and noise, etc. So these things we will cover in the course as we go on. Next important thing is the switch. So switches are used to direct the signals to their destination. In this example that you see here, let's say we are interested in sending our messages from Madrid to Helsinki. So this messages and the corresponding optical signal has to travel through the multiple of these nodes. This is a topology in Europe, optical network topology. And here important thing is how do we switch the lights at the intermediate switches? And another important thing is how do we separate an intermediate channel at an intermediate node. So this can be done through the optical switches design. So what we would like to do is to use the optical switches instead of electronic ones, because if we convert the optical light to electronic and then amplify and convert back to optical domain, it will reduce the data rate, because the speed that operates in optical domain is the speed of the light, right? And electronic speed is much lower. So what we can do is to use all optical switches that has this functionality. We can use many of these optical switches, for example, filter-based add-drop switches, mirror-based switches. So here mirror-based switches means that the micro electromechanical switch, this simply, it does not have the add-drop functionality, but it simply directs the light by tilting the mirror from input port to the output port. One important switch is the arrayed waveguide grating based switch that we will talk about in this course in detail. And another important switch is the micro resonator based ring based switch. So these things we will cover in the next lecture. And if you have any questions, please feel free to ask me. Thank you for listening, and stop by anytime if you have any questions. Thank you.